Hello everybody! In today's video, I'm going to be talking about my first machine learning project ever. Machine learning and AI in general is something I've been wanting to get into, but I never really made the time to be able to learn it properly, and I think it is so important. So this is a goal I had for 2022, and I'm excited to finally be sharing this. So before we get into the project, we'll start by just covering all of our bases. So in terms of what is machine learning, it's also called ML, and it's been called the future, but it's already starting to become heavily utilized in day-to-day life. ML is basically a subset of AI that learns from data and then makes predictions in order to solve tasks. So it can learn without being explicitly programmed. And one type of ML is unsupervised. So there's supervised, there's reinforcement, and there's unsupervised. And unsupervised is what I worked with. So in unsupervised learning, the data provided to the algorithm isn't classified or labeled, kind of how the name implies. And so it has to identify patterns and information in the training data on its own, basically. So unlike supervised learning, we don't give it any hints, suggestions, or training data. Now, one of its main use cases is clustering. And clustering is a process of splitting a data set into groups or clusters based on similarities, and we can use this for something like customer segmentation. So segmentation is when we group customers with similar attributes, which is really great for targeting communications and incorporating personalization into your business without having to do individual reach out. So if you think about a company like Google or Facebook or Instagram or Twitter, they can't just DM, all of their customers to ask them about what they prefer. It would be good to have a more standardized method, and so that's why customer segmentation is becoming something that's really common because it is really quite simple to do. So one common clustering algorithm is k-means clustering, and so that's what I worked with. This project is all about using k-means clustering for customer segmentation. So for this project, I used a dataset from Kaggle called Mall Customer Segmentation Data. And in this dataset, there are 5 variables. There's customer ID, age, annual income, and spending score. All these are useful except customer ID because it is a unique identifier of each customer, so we can kind of just get rid of it. So I did that with my code, and after that, after investigating my data a little bit as well, just like printing the head of the data so I could see it, I did a few graphs for exploratory data analysis, or EDA. And there are 3 types of EDA. There's univariate, bivariate, and multivariate. So I'm going to kind of walk you through each graph that I did. I found that, especially because it was my first coding project, sometimes, the code can be a little bit difficult or it looks a little bit like gibberish, but really helping to visualize it makes everything a lot clearer. So in univariate EDA, the data only has one variable, and so the first graph that I created was a count plot, and I got this. And we can see that there are more females than males by quite a decent amount. There are over 20 more females than males. And so that's just something to keep in mind because it's always important to know if there's a bit of an imbalance. And there is a little bit of an imbalance here with gender, which is not a bad thing, but just important to keep in mind. And so after this, I turned the gender variable to numerical, so 0s and 1s instead of female and male, which are categorical, because for our next data analysis with graphs, we're not going to be able to have categorical data. So then, as my last univariate graph, I did a disk plot, and I got this. And we can see the age values are distributed across a large range, but the age group best represented by our data is the mid-30s. So that's also good to know. If you're a company, you want to see who your main demographic is, it's good to know who is the main kind of age group. And so our main age group is mid-30s, but again, it is pretty scattered. And so moving into bivariate data analysis, bivariate is where we're dealing with 2 variables, hence bi. And so here I did quite a few scatter plots. I did 6. The first was between age and annual income. And so the highest annual income is for those between ages 30 and 50. Both ends of the scale kind of look alike. 20-year-olds get a similar annual income to 60 and 70-year-olds, probably because the 20-year-olds are starting out in their careers, and the 60 and 70-year-olds are maybe moving into retirement. The second graph was between age and spending score, and we can see that the lower the age, the higher the spending score. And so 20 and 30-year-olds have the highest spending score, and then the spending scores kind of flatten out and look similar for the rest of the age groups. Our third graph was between annual income and spending score, and this is pretty scattered, but we can see in the middle there's a group between 40 and 70K at the 40-60 spending mark. And then the fourth plot was between gender and annual income, and so we can see that males, which are mapped to 0, have a slightly higher income than females who are mapped to 1. The fifth plot was between gender and spending score. Again, this is pretty subtle, but the spending scores of males is marginally higher than that of males. And then last was between gender and age. And this is even more subtle, but the males in the group are slightly older. Okay, so now moving into our multivariate data analysis. This is a lot shorter than our bivariate. This involves at least 3 variables at the same time to understand the relationships with one another. It's really valuable to just measure the correlation. And usually we do this through a heat map, which is a graphical representation of data where the individual values are contained in a matrix and visualized with different colors. So here is our heat map, and we can see that age is pretty negatively correlated with all of the other variables: spending score, annual income, and gender. And then besides that, annual income and spending score are minimally correlated as well. So there are no super strong correlations. So that's good to know, and that is our EDA. And before we got into actually building the model, I had to standardize my data. So I did this using standard scalar. It is a function which changes the data so that the mean equals 0 and the standard deviation equals 1. And it basically works by putting various variables on the same scale, and it makes the data internally consistent. So if you were sharing your code with other people or outside with other organizations, you would want it to be internally consistent, and so this is something that you pretty much do with every model. And so now we can finally go on to building the actual model. In terms of how k-means clustering actually works, there's kind of a sequence of steps. And so the first step is picking the number of clusters for the dataset, which is k, and then randomly selecting a point as a centroid of each cluster. And then we assign each data point to the nearest centroid, compute the centroid of the clusters again by finding a point in the cluster, which is equidistant from all the data points, and then finding the points nearest to the new centroids for each cluster again, and then repeating steps 3 to 5 until the position of the centroid doesn't change. The k-means clustering algorithm's goal is to essentially just cluster similar points, which reduces the distance of the points in a cluster with the centroid as much as possible. So inertia is a measure of intercluster distances, which is the distance between two objects belonging to the same cluster. There's also intercluster distances, and so the clusters should be distinct from one another, meaning that each cluster will have unique features. And so the best algorithm will make it so that the clusters are as different from each other as possible or as far away. Okay, so onto the code. Initially, we randomly assign a value to the model, and then we can use a more specific technique to find the optimal number of clusters. So I chose 3 for my random number of clusters, and when I inputted the code for a scatter plot, I got this, and you can kind of see it's not that equally distributed. And so then I used the elbow method to get optimal number of clusters. And I also used k-means++ for our initialization technique. Basically, instead of randomization, we specify a procedure to initialize these centroids before proceeding with the standard k-means algorithm. So I got this as output, and the cluster value is where the inertia value stops largely decreasing and becomes constant, which is 5. So we have 5 clusters. And then for the intercluster distance, we can use the silhouette coefficient, which is a metric that measures how dense and well separated the clusters are. And so the metric ranges from -1 to 1, -1 being the worst and 1 being the best. So our silhouette score was 0.38, which is pretty sufficient. I put in the new numbers of clusters, and I got this new graph, which looks a lot better. In terms of actually analyzing the clusters, we can see that orange corresponds with a low annual income and low spending score, green corresponds with an average annual income and average spending score, blue corresponds with a low annual income and high spending score, and red corresponds with a high annual income and low spending score, and lastly, purple corresponds with a high annual income and high spending score. So to compare the attributes of the different clusters, we can find the average of all variables across each cluster and plot them into graphs. And for the gender variable, we can input some code to see the proportion of gender in each cluster, which basically shows us that there are more women than men. So looking at our graphs that were given, paired with the gender proportions, we can divide our clusters with attributes. So our cluster 0, which is the violet cluster, these are people in their early 40s. They have kind of a 55K annual income, which is average, an intermediate spending score of 49, and they are predominantly female. In cluster 1, we have people in their late 30s with about an 86K annual income, so high, a low spending score of 17, and this group is more or less equal in gender. In cluster 2, we have a high annual income, a high spending score. The annual income is around 85K and the spending score is around 82. These people are in their early 30s, so they're a bit younger. And again, predominantly female. Big surprise. And then cluster 3, we have people in their mid 40s with about a 26K annual income, so low. And then also a low spending score of 21, and they're also predominantly female. And in cluster 4, we have people in their mid 20s, with about a 26K annual income, but a very high spending score of 78, and they are predominantly female once again. The final step was creating personas around these clusters. So, for example, with cluster 0, this is a group of people who make and spend their money on an intermediate level. And so we can recommend discount coupons and family packages. Cluster 1 is, the careful spenders. They have a high annual income, they have the highest spend out of all the clusters, but also the lowest spending score. So we can recommend them special offers, promos, discount coupons. Cluster 2 is more of our affluent individuals, and so to them we can recommend investment properties, car deals. Cluster 3, it's likely that they're nearing retirement because the group is the oldest in age. They have both a low annual income, low spending scores, and so we can recommend healthcare products and promos. And then lastly, cluster 4 is our impulsive buyers. So they're young, they spend above their means, and so we can recommend to them travel coupons for clothing, makeup, and skincare. Machine learning is already impacting every industry, and this project was actually super fun. I'm excited to start working on more projects, expand my breadth in AI a little bit, and as always, if you have any feedback, please feel free to reach out to me. Thank you so much.